I'm Mark. I'm Will.
I'm Diesel Dom. This is our video project.
I'm gonna roll this rim-weighted tire down the hill, and then the center-weighted rim. You ready? 1, 2, 3.
Alright, so now we're going to roll both of them down the hill to see which one goes faster. Ready?
Oh, we're going off track. Okay, so the reason why the tire went faster than the rim was because the tire is rim weighted and the rim is center weighted, so the tire accelerates faster. And another reason is because the surface area on the tire is a lot greater. Unlike the surface area of this rim, it just has two little strips on the ground. And the tire is also rubber and this is metal, and the rubber rolls a lot faster and it rolls a lot smoother on the road than the metal would. And yeah, that's pretty much why the tire made it down the hill faster.
Alright, for this demonstration we're going to shoot a bow and arrow at 0 degrees, 45 degrees, and 90 to see which one goes the furthest.
This is a 0 degree angle. Obviously that went way too short. Let's fire another one. Now we're shooting it at a 45 degree angle.
Oh, so close.
That one went really far. Let's go 90 degrees. Now we're gonna shoot it at a 90 degree angle, but for our own safety we're shooting it a little bit under 90 degrees. Where'd it go? I have no idea where it went.
It's right over here.
But, oh, here it is. Well, as you can see in a second, the arrow went way short of our target over there.
If I was an actual accurate shot with a bow and arrow, this is what would have happened. The 90 degree would have landed here, and this is because it had the most time in the air with gravity pulling it down the most. And then 0 degrees would have landed here because it had gravity pulling down on it, but it had the least amount of height. 45 would have landed there because gravity was pulling down on it and it was falling faster, yet it still had the height to carry it the distance.
Good explanation, Will.
Okay, we're about to do the physics of a burnout.
Oh, this tire's the one that slipped. I don't care.
There's Diesel Dom for you. Yeah.
Alright, the physics of the burnout. The way this works is the power from the engine goes to the rear wheels, but the brakes are holding the rear wheels. But since there's more power going to the wheels than the brakes can hold, they break free, causing the wheels to spin on the asphalt, causing friction to happen, which makes the wheels burn up and smoke.
Okay, so today we did 3 different demonstrations. The first one we did was the physics of rim weight versus center weighted wheels, and obviously the rim weighted wheel rolled faster because it had a higher acceleration and because the surface area was greater. We had the physics of trajectory, where we fired an arrow at 0 degrees, an arrow at 45 degrees, and an arrow at 90 degrees, and the 45-degree one went the farthest. And then we also did the physics of a burnout, where we locked up the brakes and then pressed the gas, made the wheel spin. There was a ton of smoke. It was pretty cool. And hopefully you all learned a lot from this lesson in physics. Go Team Conceptual.
All right, let's go to class.